Okay, so good morning everyone. This is going to be our last content lesson on the behaviour of polynomials. Friday's lesson is going to be a bit of a review lesson of the last couple of weeks. So what we're going to be doing today is looking at how to describe and how to predict and describe how polynomials will act as they approach negative infinity and positive infinity. So what is the end behaviour of polynomials? All right, so just checking in first up, so either write it in the discussion board or the notes that you are going to be sending me. Make sure you're keeping track of this. So we will be having another live session on Friday during Friday's lesson. So please make sure that you're checking in at the start of that as well. All right, so first of all, what I want you to do is list the steps for finding the turning point of a quadratic function, and then list the steps for finding the turning points of a polynomial function. How are they different? How are they similar? Okay? And that is the content of Monday's lesson. Okay, so we're looking at the end behaviour of a polynomial. Now, don't copy down this slide. The next slide is a little bit more intuitive. So, in order to predict how a polynomial is going to behave as it approaches as x approaches positive and negative infinity, we need to look at the largest degree. Okay, so if it's an x to the power of 4, we're going to x to the power of 4 plus x to the power of 3 plus x to the power of 2 plus x plus 1. We will only be looking at the x to the power of 4. So you're looking at the greatest degree. Okay, so what we're looking at is whether the coefficient, which in here is represented by an a, whether the coefficient is positive or negative, and whether n is odd or even. Okay, so if a is positive and n is even, then both n's will approach positive infinity. So as x approaches negative infinity, y will approach positive infinity. And as x approaches positive infinity, y will approach positive infinity. If the coefficient a is negative and n is even, then both n's are going to approach negative infinity. So n being even means that both n's are going to approach the same infinity, whether positive or negative. Whereas if n is odd, then one side will approach negative infinity and the other side will approach positive infinity. And whether a is even or whether a is positive or negative will determine whether those two are correlated or not. So like I said before, don't copy down this slide. The next slide is more intuitive, and we'll pop to that now. So if a is positive and n is even, then we're going to have something that looks like this. We're going to be having the two ends both approach y is a positive infinity. Now, if a is negative, but n is still even, we're going to have the opposite. The two ends are going to be approaching negative infinity. A is positive and n is odd. Because n is odd, our two ends are going to be approaching different infinities. And because a is positive, we are going to have an increasing. So as x approaches negative infinity, y approaches negative infinity. And as x approaches positive infinity, y approaches positive infinity. And if n is odd and a is negative, we are obviously going to have the opposite of that. So if x approaches negative infinity, y approaches positive infinity, and as x approaches positive infinity, y approaches negative infinity. So this are our four combinations. And remember, this is only looking at the largest degree. Okay, so the leading degree. So let's describe this formula, and we have it here. So we already know what it looks like. We know that both ends are going to approach negative infinity. Let's see how we're going to find that. So the first thing we want to do is we want to find the x-intercepts. So to find the x-intercept, we need x squared minus 3 to be 0, and 4 minus x squared to be 0. So if x has to equal square root of 3 and square root of 4, which is 1.72 and 2, and it can also be negative 1.72 and negative 2, which is what we see here. Negative 2, negative 1.72, 1.732, positive 2. Okay? So we have 4. Then we have to identify the y-intercept. I've actually gone and expanded this out to find it to be negative 12. It should be negative 12, sorry. But I just realised that you could have just made x squared be 0, x squared be 0, so negative 3 times 4 is negative 12. That would have been a million times easier than what I did. So, yeah, I would actually recommend just do that. Okay, but then looking at what we are doing here. All right, so for this you actually do have to expand. So we have a negative x to the power of 4, negative x to the power of 4. So a is negative 1, so a is negative. N is 4, so n is even. A is negative, n is even, therefore y approaches negative infinity as x approaches both positive and negative infinity. And we write this like this. As x approaches infinity, y approaches negative infinity. As x approaches negative infinity, y approaches negative infinity. And that's how you write this, okay? So this is the new content, this is step 3. And what I want you to do, I want you to apply that knowledge to these two polynomials, okay? Should be relatively simple for you guys, just follow those 3 steps. Once you've done that, I want you to consider what's the better measure of spread, median or mean, and support your claim. And this is a matter of opinion. So I don't want you to go and copy this down. I want you to read through this and think, what argument is the author trying to make? Okay, so just in a single sentence, summarize what argument the author is trying to make and whether or not you agree. This can be 2 sentences. What the argument is and whether or not you agree. Okay, as always, I'll be on the discussion board. Please come and touch base.